Welcome back. We are on chapter 6, rational expressions, and we will work today on section 6.1, rational functions, multiplication and division of rational expressions. The first objective is to find the domain of rational expressions, and we just need to understand that rational expressions are written in the form P over Q, where P and Q are both polynomials and Q is different from 0. Some examples here of how the rational expressions are going to look like. And to find the domain of a rational expression, we have to make Q different from 0. We have to make a condition that Q is different from 0. Because if you divide anything by 0, this is going to be undefined, right? So you cannot divide anything by 0. You don't want this this rational function to be undefined. Let's check the first example here, and we have 8x cubed plus 7x squared plus 20. All this expression over 3. What do you say about the denominator? Is the denominator different from 0? Yes. So that means x is going to be any number, any real number. X is going to be equal to any real number, can be equal to any real number. There's no restriction. Now it's going to be different next example. 5x squared minus 3, all this expression over x minus 1. Now we have to make x minus 1 different from 0. And applying addition property here, let's add both sides 1, x different from 1, right? That means that the domain here is any real number. The domain in this second example, example letter B, is x such x is different from 1. Next example, letter C. We're gonna have to do the same thing. We're gonna check this denominator here and make the denominator x squared minus 2x minus 15 different from 0. What would make this denominator equal to 0? That's what you're gonna find first. And to find out what makes this denominator equals to 0, let's factor the denominator. We're gonna find the number, two numbers that multiplied, the numbers are going to be equal to negative 15, and the sum, the numbers, the two numbers are going to be sum negative 2. And I can think right now about 3, negative 3, or negative 3, or positive 3 and 5. Yeah, positive 3 and 5. If you multiply positive 3 and 5, you're gonna have negative 5. Negative 5. If you multiply, you're gonna have negative 15. And if you add positive 3 with negative 5, we're gonna have negative 2. So this is going to be the numbers we will use to factor out this expression. We can write x squared minus 2x minus 15 equals x plus 3 times x minus 5. That means what makes this expression here equals to 0 is 3, negative 3 and positive 5. Since this expression needs to be different from 0, x needs to be different from negative 3 and x also different from positive 5 or 5. The domain is going to be x such that x is different from negative 3 and x is different from positive 5. So simply to state in a very simple manner, to find the domain, you're going to make the denominator of the rational function different from 0 and find what are the numbers that you have to avoid, right? That you have to exclude from the domain. And you're going to exclude these numbers from the domain because these numbers are going to make the denominator equals to 0. Moving on, and now next objective, simplifying rational expressions. To simplify a rational expression means writing it in lowest terms or simplest form. And the fundamental principle of rational expressions is that for any rational expression p over q and any polynomial r, where r different from 0, you're going to have p multiplied by r over q multiplied by r is equal p over q times r over r, and then you can simplify. You simplify here, r divided by r equals to 1, and then you have something simpler. It's just p over q. Step by step for simplifying rational expressions. First step, completely factor the numerator and denominator of the rational expression. Second step, divide out factors common to the numerator and the denominator. And warning, 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 only common factors can be eliminated. And by eliminated, we're talking simplified. Make sure any expression you eliminate is a factor, and let's see what it means when we work on the examples, okay? Let's work out this one. Simplify the following expression: x squared plus 3x minus 4, or this expression, over x squared minus x minus 20. And then we have to factor the numerator, factor out the numerator, factor out the denominator. How can we write the numerator as factors, a multiplication of two different factors? We have to find two numbers that multiplied is equal to -4 and sum equals to 3. Two numbers that multiply is -4 and sum equals to 3. And I can think about -1 and 4. Check it out. Multiply -4, sum -1 plus 4, 3. So we can factor out this as x minus 1 times x plus 4. Excellent. Now the denominator. Let's find two numbers. Let me get more space here. Sorry. Two numbers that multiply is equal to -20. Two numbers that multiply equals to -20, and the sum equals to -1. Think about it. Two numbers multiplying -20, sum -1. I'm thinking about -5 and 4, because I multiply -5 times 4 to -20, -5 plus 4, 1. So we can write here x minus 5 times x plus 4. We substituted the numerator by its factors, this is equal to the numerator, and we substituted the denominator by its factors as well. Those are factors that multiplied are going to be equal to the denominator. And what we can do, since we have a common factor, this common factor here, x plus 4, we can divide x plus 4 over x plus 4 is equal to 1. And this is what means simplifying, because now we can rewrite this fraction, this rational expression, as x minus 1 over x minus 5. This very complicated rational expression here is going to be equal to this much simpler rational expression. Moving on to the next example. Now we have 7 minus y over y minus 7. May we simplify this? Can we simplify this? Let's think about it. We can let's rewrite this as negative y minus 7, because I can see it's kind of the same, but with the inverted sign, right? So I'm rewriting this negative y minus 7 over y minus 7. This means we can simplify. We can divide y minus 7 over y minus 7 is 1. This is equal to negative 1. So this is the simplification of that rational expression. Let's work this example now, and then I have x cubed plus 8 over x plus 2. And if we remember chapter 5.7, where we have seen special products, right, to help factoring, we're going to remember that there's one way of factoring the sum or difference of two cubes. And this is, we can rewrite the top here, the numerator, as x cubed plus 2 cubed, right? So this is going to be the sum of two cubes. We can factor it out. It's a special product. If you remember, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared, right? This is the formula, so let's apply this formula here. A plus b, x plus 2, times a squared, x squared, minus ab, 2x, plus b squared, 4, over x plus 2. And that's very convenient, because check it out, now we find a common factor on the numerator and the denominator that we can simplify. We can simplify, divide x plus 2 by x plus 2, then I have 1. And this now this rational expression here is going to be equal or equivalent to, let's write down and then right here, x squared minus 2x plus 4. This is the simplification of that rational expression. Moving on to one more example. Now we have 2y squared plus 2 over y cubed minus 5y squared plus y minus 5. And we can factor this out as, well, we can see here that we have a common coefficient, a common number that we can factor out, number 2, y squared plus 1, right? And underneath here we're gonna factor this out, because we can identify right here we have y squared, right? Y squared that you can factor out. Y squared times y minus 5. Y squared times y minus 5, right? Plus y minus 5. Check if you're following. I factor out only here this, that is y cubed, then is y squared times y, and this is negative 5y squared is negative 5 here, y squared. Okay. Let's keep working because we can simplify it even further. 2 times. Let's just repeat the numerator and let's work on the denominator. And now we have this common factor here, this common factor that we can also factor it out. You can factor and make y minus 5 multiplied by y squared plus 1. Very interesting, very convenient, because we can now simplify, because y squared plus 1 divided by y squared plus 1 equals 1. So the rational expression, the remaining rational expression is going to be this one. The simplified rational expression is going to be this. 2 over y minus 5. Okay. See this? This is the original. And by factoring and simplifying, we got this much simpler rational expression. Finished with the examples, let's go to the next objective. Objective number 3, multiplying rational expressions. The rule for multiplying rational expressions is, if you have one rational expression is p over q, another one is r over s, p over q times r over s is equal to, you're going to multiply all the numerators, p times r, over, and then I'm going to multiply all the denominators, q times s, as long as q and s are different from 0. Step by step, completely factor each numerator and denominator. Second step, use the rule above and multiply the numerators and denominators. And third step, simplify the product by dividing the numerator and denominator by their common factor. Checking out the example that we have here. And this is one rational expression. It is parenthesis m minus n. Close the parenthesis, is squared, the whole thing is squared, over m plus n. And you're going to multiply by another rational expression, it's this one. M over m squared minus mn. So, can we, let's check this step by step here. Completely factor each numerator and denominator. Use the rule above and multiply the numerators and denominators. Can we factor it a little bit further? Let's see. Well, I cannot see anything that we can factor out here. It's already good. So we're gonna repeat m minus n squared over m plus n. Multiplied. And here we have m, okay? But this denominator, we can factor it a little bit. We can simplify it a little bit. We can factor m out, multiply by m minus n. See? So we can simplify. Now we're going to multiply all the remaining factors on the numerators. That's going to be m minus n squared times 1 over m plus n times m minus n. this is how you do, right? Remember here the step by step. Multiply all the, use the rule above, that means multiply all the numerators and then multiply all the denominators. Now let's check if we can simplify anything. And here we have m minus n squared, and underneath we have a similar factor, m minus n. We can simplify. This square is going to be simplified with this, right? Because we're going to divide one of the m minus n here by m minus n. This is going to be 1 and simplify. It's possible. Then we have m minus n over m plus n. Check it out, compare. This is the rational expression, the resulting rational expression that is resulted from multiplying two different rational expressions and then simplifying all the common factors. Okay, moving on to the next objective, number 4, dividing rational expressions. And very interesting, dividing rational expressions, because the rule for dividing rational expressions is this: P over Q divided by R over S is going to be equal to P over Q multiplied by S over R. Now we just multiply the numerators, then multiply the denominators, and you have the answer, the result. As long as Q different from 0 and S different from 0 and R different from 0. The procedure is to divide by a rational expression, use the rule above and multiply by its reciprocal, then simplify if possible. Let's work on an example to see how to proceed. Check it out. We have this rational expression here, and parentheses x plus 3 plus parentheses squared divided by 5 over 5. I mean, this is the rational expressions divided by 5x plus 15 over 25. To operate this division, what we're going to do, repeat the first rational expression, the first term, over 5. Change it to multiplication. Now this is going to be a multiplication, and invert. We're going to use the reciprocal. 25 over 5x plus 15. That's it. Okay, equal, and we can multiply numerator and multiply all the denominators. Check it out, very interesting. You can simplify. This is going to be 25 divided by 5. 5 here. But pay attention, because there's another thing that we can factor out and simplify here. Check it out. Let's rewrite. We simplified once, but we can simplify even further. We can factor out 5 here. See, 5 times x plus 3. 5 times x, 5x. 5 plus 3. 15. 5 times 3, 15. And for the simplification, and this square here, we can simplify with that denominator, and finally we will have a solution for the division. X, we don't need this parentheses anymore. X plus 3. Much simpler. So this is the result of the division of those two rational expressions. Now that's a large one, a large operation that we have to work on. Let's try to solve it. And we have here 18y squared plus 9y minus 2, everything, all this expression over 24y squared minus 10y plus 1 divided by, and the other rational expression is going to be 3y squared plus 17y plus 10 over 8y squared plus 18y minus 5. And we need to factor out all these expressions here to be able to think about a simplification. But the first thing we're gonna do actually is apply the procedure to divide two rational expressions. So we're gonna repeat this first rational expression here, repeat the same thing, 10y plus 1, okay, multiplied by, now you're gonna use the reciprocal of the next one, we're gonna invert, right, 8y squared plus 18y minus 5 over 3y squared plus 17y plus 10. And we have to find out how to factor out these expressions. I'm gonna show you here how to factor this kind of polynomials. Let's say the quadratical expressions here. Let's get this example: 18y squared plus 9y minus 2. Okay, and let's see how to factor this out. First thing, you have to find two numbers that multiply is equals to, this is A, this is C, A times C. A times C equals negative 36. And have to find, and these two numbers, the sum needs to be equals to B, this, 9. So two numbers that multiplied is equal to negative 36 and the sum is equal to 9. We can guess a few numbers, but I'm thinking here the number that actually is going to help us, the pair of numbers that are going to help us is going to be 12, right, and negative 3. Because you multiply negative 3 by 12, negative 36, and 12 minus 3, 9. The way you do this kind of thing is by guessing numbers, trying, and then you're gonna find a pair. And later in the course, we're gonna work with, we will show, or we will learn how to use the quadratic equation. That will make things a bit easier. But right now, you do like this and substitute here, but then you're gonna write 18y squared plus 12y minus 3y. See, you're gonna substitute, we're gonna rewrite this term 9y as 12y minus 3y minus 2. Now we're gonna factor out here whatever we can, and we can factor out here 6y, right? 6y. Then we're gonna have here 6 times 3, 18, y squared, okay, plus 6 times 2, 12, minus, and let's factor out here 3y. negative 3y minus 2, let's factor out negative 1 or minus, the minus sign. 3y plus 2. And then we have a common factor that we also can factor out. This is going to be 6y minus 1 times equals 6y minus 1 times 3y plus 2. This is the way. It's a little bit of a hard way, as I told you. In the future we're gonna learn how to use the quadratic equation that make things a little bit easier. But this is one way to find out how to factor this expression here and find that's going to be equal to that multiplication of two factors. Let's substitute this up here, and actually the other ones I'm gonna use numbers that I have calculated, but you know that the procedure, the process to calculate is this one right now. And I'm not gonna lie to you. This is not too easy, but later it's gonna become easier as soon as we learn how to use the quadratic equation later in this course. Let's substitute. This is equal, and then I have here calculated, and I have the factors 6y minus 1 times 3y plus 2 is equivalent to that expression over, and equivalent for the denominator here is going to be 6y minus 1 times 4y minus 1. Let me fix this. Multiplied by, now the equivalent to this numerator is going to be 4y minus 1 times 2y plus 5, and the equivalent to that denominator now is going to be 3y plus 2 times y plus 5. Okay, repeating, this denominator is equivalent to these factors, the numerator here is equivalent to that, this one is equivalent to that, and that one is equivalent to this. Okay, because when we factor out like this, we can simplify, and that's our objective, to simplify and be able to find a simpler and solution, a simpler rational expression that's going to be the solution for this problem that we are working on. And check it out. We can simplify 6y minus 1 with 6y minus 1 right here, and we can simplify anything else, not yet, but after we do the multiplication, let's do the multiplication first. We simplify this, and we can simplify it even more. 3y plus 2 multiplied by 4y minus 1 multiplied by 2y plus 5 over, then here 4y minus 1 times 3y plus 2 times y plus 5. Okay, check out if you can simplify anything else, and actually we can. We have 3y plus 2 that you can divide by 3y plus 2, simplifies, it'll be equals to 1. 4y minus 1 that you can divide by another 4y minus 1 is 1. And the remaining fraction, or the remaining rational expression, is going to be 2y plus 5 over y plus 5. Now let's work this example. Perform the indicated operation. X squared minus 25 over, and we have x plus 5 squared, times 3x plus 15 over 4x, divided by x squared minus 3x minus 10, all this expression over x. Let's factor out whatever we can to simplify. So first let's check this expression here, this numerator here. Remember, this is something that we can write as x squared minus 5 squared. And remember, there's a special product, a squared minus b squared, that we can rewrite as a plus b times a minus b. So let's write here x minus 5 times x plus 5. This one. X minus 5 times x plus 5 over x plus 5 squared. Great. Next one, this 3 times x plus 15. Actually you can factor out 3 x plus 5 over 4x. And this division here, remember, the procedure is we can we can change into a multiplication, and then we invert. We're gonna use the reciprocal, x over, and then you have here x squared minus 3x minus 10. Find for this one, find a number that multiplied, two numbers that multiplied is equals to negative 10, and the sum equals to negative 3. Let's think a little bit, and of course we can use 5 or negative 5 and 2. We can use negative 5 and 2, because negative 5 times 2, negative 10, negative 5 plus 2, 3. And we can rewrite this as x minus 5 times x plus 2. Correct? So let's factor out and rewrite this as x minus 5 times x plus 2. Very good. We will be able to simplify a lot of things. So what we're gonna do now, we can actually let's multiply numerators and multiply denominators, and then we simplify. Okay, x minus 5 times x plus 5 times 3 times another x plus 5 times x over x plus 5 squared times 4x times x minus 5 times x plus 2. Wow! Simplifying now. I'm probably gonna have a lot of things to simplify. Check. X plus 5 times x plus 5 is squared, and we can simplify with this one. X minus 5, we can simplify with this, x minus 5. And we have an x here, that we can simplify with that one. And that's pretty cool, because the only thing that's left, the few things that are left are this 3 and a 4 here, and the x plus 2 over there. That is going to be the result of all the multiplications, divisions and simplifications, and that's the answer for this example. Now let's work on objective 5, using rational functions in applications. And let's go straight to an example here, and let's read through this example. For the ICL production company, the rational function Cx equals 2.6x plus 10,000, all this expression over x. Describe the company's cost per disc of pressing X compact discs. Find the cost per disc for pressing A, 100 compact discs, B, 1000 compact discs. We have the function, right? And the function is here, is a rational function. Cost a function of x, right? Cost a function of x is the number of discs being pressed. 2.6 x plus 10,000 over x. If x equals 100, we're just gonna plug in 100 here on this function. Equals 2.6 times 100 plus 10,000 over 100. And if we get the calculator and make all the calculations that we have here, 2 times 6 times 100 plus 10,000 over 100, and the result is going to be 102.6. This is the cost if you press 100 compact discs. And if you press 1000, it's going to be kind of the same process. If x equals to 1000, you just need to plug in 1000 here on the function. So 2.6 times 1000 plus 10,000 over 100. That means cost, if you press 1000, equals, and if you do the calculations here, you're gonna find $50.80. Let's work another example. A company's cost per book for printing X particular books is given by the rational function Cx equals 0.8x plus 5,000 over x. Find the cost per book for printing 100 books and 1,000 books. Let's find first for 100 books, and this is kind of similar to the previous problem, right? We just plug in x equals 100 here, and it's going to be 0.8 times 100 plus 5,000 over 100. And we can simplify a little bit, and actually let's get the calculator and do this together. Calculator, okay, and typing 0.8 plus 50 equals, and this divided by 1, yeah, 50.8. 50.8, and this is dollars. Now let's check C for 1,000 books, the cost for 1,000 books. And same thing, 0.8 times 1,000 plus 5,000 over 1,000. And now I can simplify and check. This result is going to be 0.8 plus 5, 5.8. $5.80 for 1,000 books is going to be $5.80, and for 100 books is going to be $50.80. that concludes section 6.1. Thank you for watching.